Welcome to Space India channel. This channel is about space, astronomy and astrophysics. Now I am going to explain you about evolution of string theory. A famous, controversial and often misunderstood story about the nature of everything. We know that string theory is an important theory of modern physics. Let us revisit the evolution of string theory. We all think this theory is a modern theory. But the actual start of string theory held on 1867. Before relativity and quantum theory. Yes, in 1867 Lord Kelvin, Sir William Thomson, published an article in the Proceedings of the Royal Society of Edinburgh, Volt. Vide, 1867, pages 94 to 105, in which he proposed that atoms consisted of vortex rings in the ether of space. Such vortex rings could be linked together to form complex structures. The title of Kelvin's article was on vortex atoms. Atoms were known to exist because of the constant proportions demonstrated in chemical reactions. However, this article was from a time before the existence of electrons was known. Experiments by J. Thomson in 1897 led to the discovery of the electron as a fundamental building block of matter. Experiments by others led them to the same conclusion, and the name electron was coined by someone else. In 1919, the German mathematician Theodor Kaluza formulated a theory based upon the general theory of relativity, but involving 4 spatial dimensions rather than 3. From his theory, Kaluza got electromagnetism as an implication. This held out the possibility of uniting gravity and electromagnetism. Albert Einstein liked Kaluza's work and supported its publication. After him, the next key event happened on 1968. In 1968, Gabriele Veneziano originally proposes the dual resonance model. Gabriele Veneziano worked for about a year at CERN to develop a theory of the nuclear strong force as manifested in the interaction of hadron particles, a function that he found which played an important role in his theory. In a book of mathematical functions, he discovered a name for this function. It was called Euler's beta function. Somehow this story got changed into the notion that he discovered the beta function as a function that would explain the strong force. That version neglects the year he spent deriving the mathematical function. In the book, he only found out that the function had a name. Who would have thought, from the title of Veneziano's article, construction of a crossing symmetric Regge behaved amplitude for linearly rising Regge trajectories, that it would launch a major intellectual effort. This effort by Veneziano is taken to be the foundation of string theory, although at that point it was not known that the analysis could be interpreted as pertaining to strings. Another researcher at CERN, Mahiko Suzuki, at the same time independently developed the same analysis as Veneziano. After that, in 1970, string theory is created when physicists interpret Veneziano's model as describing a universe of vibrating string. In 1971, supersymmetry is incorporated, creating superstring theory. There need to be equal number of bosons and fermions in the non-bosonic versions of string theory. In 1973, a scientist by the name of Goldstone published paper on string quantization. Generated interest in the field. In 1974, string theories are shown to require extra dimensions. An object similar to the graviton is found in superstring theories. Strings with closed loops are a candidate for gravitons, which mediate the force of gravity. In 1976, supersymmetry is added to gravity to form supergravity. In 1984, the first superstring revolution begins when it's shown that anomalies are absent in superstring theory. By all this was biggest year for string theory. Deadly anomalies that threatened to make the theory senseless were discovered to cancel each other when the underlying symmetries in the theory belong to special groups. Finally, string theory is accepted by the mainstream physics community as an actual candidate theory uniting quantum mechanics, particle physics and gravity. In 1985, heterotic string theory is developed. Calabi-Yau manifolds are shown to compactify the extra dimensions. In 1991, the different flavors of superstring theory were found to transform into one another using duality. In 1995, second superstring revolution started. Edward Witten proposes M-theory as unification of superstring theories, starting the second superstring revolution. Joe Polchinski shows branes are necessarily included in string theory. M-theory was used to explain a number of previously observed dualities, using which one string theory could be transformed into another. M-theory requires 11 dimensions and higher dimensional objects called D-branes. M-theory is widely regarded as the theory of everything. In 1996, string theory is used to analyze black hole thermodynamics, matching earlier predictions from other methods. In 1996, ad CFD correspondence. It is a concrete realization of the holographic principle, which has far-reaching implications for black holes, locality, and information in physics, as well as the nature of the gravitational interaction.